Hi friends, in this video we are going to discuss about the concept of Thevenin's theorem. So this concept is very important for electrical networks. And what is the main purpose of this particular Thevenin theorem is to find the responses in any network. So it is very simple to get the responses while we are going to converting from the complexity of network into the equivalent circuit provided by the Thevenin's theorem. Okay, so before we are going to enter into the actual concept, just first we are going to understand the definition. Now see here, the statement of this particular Thevenin's theorem is, it states that any linear circuit containing several voltage sources and several resistances can be replaced by just one single voltage source in series with a single resistance connected across the load terminals. Okay, so what is the meaning of this statement means, if suppose we are having one network like this, and in this particular network we are having V1, V2, V3, three voltage sources are there, and R1, R2, R3, R4 are the four resistances we are having. It means in this particular network we are having several voltage sources like V1, V2, V3 and several resistances like R1, R2, R3, R4. Clear? Now what we need to do, by using the concept of this Thevenin's theorem, we are going to converting this particular network into the equivalent circuit provided by the Thevenin's theorem. But what is the equivalent circuit provided by the Thevenin's theorem means? Just a simple voltage source, that is VTH. VTH represents the Thevenin voltage, and here RTH represents the Thevenin resistance. It means in this particular network we are having V1, V2, V3. Now what we are doing, by converting this particular network into this particular equivalent circuit, and this all voltage sources are becomes just one single voltage source, that is VTH. And here R1, R2, R3, R4 are the resistances available in the original circuit. But by using the concept of Thevenin's theorem, we are converting all these four individual resistances into single resistance, that is RTH. Here RTH represents the Thevenin resistance. Clear? But how we are going to converting this particular given complexity network into this particular network? So that is a concept we need to discuss now. Clear? So now I will take one example, and along with that example I will discuss step-by-step procedure, and by discussing step-by-step procedure we are going to solve that problem. You will get full clarity how we are going to apply Thevenin's theorem, and also how we are going to this particular given network, we are converting the given network into this particular equivalent circuit. Clear? Now see here the step number 1. Now so before that, what I will do, first I will take one question like this. So question is, find the current flowing in 10 ohm resistor for the following network by using Thevenin's theorem. Okay, so our target is to find current flowing in 10 ohm resistor by using the concept of what? Thevenin's theorem. Now see, I will take one network here. So please listen carefully. If you are understanding this problem means, so you do not have any questions in the Thevenin's theorem after watching this video. So here I am applying V is equal to 10 volts, and this R1 is equal to, for example I am taking 2 ohms, and here R2 is equal to 6 ohms, and this R3 is equal to 10 ohms. Clear? So this is a actual network we are having. Now see here, so just see here in this problem, what is the question actually? Current flowing in 10 ohm resistor. 10 ohm resistor means this one only now. So this particular resistance is a 10 ohm resistance. Now what is the step? What is the first step in the Thevenin's theorem means? First step is, so first we are going to taking, so this is the first procedure. Now in this step number one is identify the load resistance. Identify the load resistance in the given network. Okay, so identify the load resistance in the given network. Here the load resistance means what? Where we are finding the response, or in which branch we are finding the response, that particular resistance is the load resistance. Clear? Now in this problem, 10 ohm resistance, we need to find the current flowing through this particular 10 ohm resistance means this particular 10 ohm resistance is the load resistance. Clear? So here we are, just see here, identify the load resistance in the given network means we identified that in the given network, that is what? R3 is equal to 10 ohm is the load resistance. Okay, so this one is the load resistance. Clear? That is clear. Now step number 2 is disconnect the load resistance. Disconnect the load resistance from the original network. Okay, so what is the next step? Actually disconnect the load resistance. It means in step number 1 we are identifying the load resistance, that is R3 is equal to 10 ohm is the load resistance. Now step number 2 is disconnect the load resistance from the original network. Okay, so disconnect the load resistance from the original network. Now if you are going to disconnecting the load resistance from the original network, the network will becomes like this. Just see here. So just we are disconnecting this particular load resistance. So this one is R1 is equal to 2 ohms, R2 is equal to 6 ohms, applied voltage V is equal to 10 volts. Clear? Now in this problem, R3 is the load resistance means if you are disconnecting this load resistance from this original network means then this particular network, original network will becomes like this. Clear? So after the disconnecting, we are going to see 1, 2 open terminals in this particular step. Now step number 3 is calculation of Thevenin resistance across the open terminals, where we disconnected the load resistance. Okay, so the step number 3 is what? Calculation of Thevenin resistance, that is what? RTH across the open terminals where we disconnected the load resistance. It means what? We are disconnecting the load resistance in this branch means A and B are the open terminals. Now we need to find the RTH across this particular terminals. Now when we are going to finding this particular RTH, that is Thevenin resistance across the terminal A and B, we need to apply some rules. That is, when we are going to finding the value of RTH, if in this particular network having any voltage source like V is equal to 10 volt source, then this particular voltage source is short circuited, and if there any current source is there, then that particular current source is becomes or will act as an open circuit. Clear? It means in this particular network, we are having only one voltage source. Okay, so this particular voltage source will becomes the short circuited. It means the condition is when we are going to finding the value of RTH across any terminal like A and B. So across this we are finding RTH means in that case or in that time all voltage sources are short circuited and all current sources are open circuited. Now in this particular problem, if we are finding the value of RTH means then this particular voltage source is acting as a short circuit. Now see here, if you are going to draw this particular network, again here it will becomes like this. Just see here. So instead of voltage source we are placing short circuited. It means what? While we are calculating the value of Thevenin resistance across this open terminals, so in that case the not only this voltage source, if suppose in this particular network we are having 10 voltage sources and 5 current sources for example, then all voltage sources are short circuited, all current sources are open circuited. But in this problem we are having only one voltage source, that is V is equal to 10 volt source in place of this. So just we are short circuiting this particular path. Clear? Now what is this value? R1 is equal to 2 ohms. This one R2 is equal to 6 ohms. Now see here, we are finding the RTH across terminal A and B in the right side means always we need to reduce the network from left side. Now here by observing this particular left side, R1, R2 both are connected in parallel. Yes or no? So here R1 and R2 both are connected in parallel. Both are connected in parallel. Then the value of RTH, then RTH across is terminal A and B only na. So the value of RTH is equal to, so product of R1 R2 divided by addition of R1 and R2. Clear? That is equal to R1 is how much? 2 and into R2 is how much? 6 divided by the value of R1 is 2 plus the value of R2 is how much? 6. Now here RTH is equal to, so 12 divided by 8. 12 divided by 8. If you are going to solving this 12 divided by 8, so you will get what? So 12 divided by 8 means definitely you are going to get 1.5 ohms. Clear? So this 1.5 ohms is the value of RTH. Okay. So after getting this value, just we need to substitute this RTH in this particular network. Now here just see here. So here RTH, this is terminal A. It means we are going to get the value of 1.5 ohms, the combination of R1 and R2 like this. Clear? So this is the third step. And fourth step, step number 4 is, so just see here, in this particular network, so we are converting the given network into this particular equivalent circuit means the calculation of RTH in the given network is clear. Now the remaining is what? The calculation of VTH is remaining to convert from this particular network to this particular network. Now the RTH value is clear now. Now we need to find the value of VTH. Now when we are going to finding the value of VTH, what we need to do? Again this VTH value are also calculating across the terminal A and B where we disconnected the load resistance. Clear? So here the calculation of the Thevenin's voltage. So calculation of Thevenin voltage across the open terminals, where we disconnected the load resistance. Okay, it means what? Actually, in the given problem, first we are identifying the load resistance. After identifying the load resistance, we are disconnecting that load resistance. After disconnecting, that particular branch will becomes two-terminal open network. Now across that particular terminal only, we are calculating the value of Thevenin resistance, and also we are calculating the value of Thevenin voltage. Clear? So that is the reason why calculation of Thevenin voltage across the open terminals where we disconnected the load resistance. Now actually, what is the actual circuit after disconnecting the load resistance? This only. So this particular network is the actual network after disconnected the load resistance. So this one is R1 is equal to 2 ohms, and we are applying the value of V is equal to 10 volts. Now again we need to find the value of this one, VTH across the terminal A and B only. Now see here, the most important point when we are going to finding the value of this particular VTH means VTH, we are calculating terminal A and B. That we are going to calculate the value of VTH across the terminal A and B means, so how it is possible? Whatever the voltage drop we are getting across the terminal R2, that same voltage drop directly appearing across terminal A and B. Yes or no? Because this is a parallel network if you are going to consider the terminal A and B. It means we are calculating the value of VTH across terminal A and B means the value of VTH is the voltage drop across R2. Yes or no? It means when the current is flowing through this particular R2, that current multiplied with this resistance R2 will give the voltage drop across R2, and that particular voltage drop directly appearing across terminal A and B. So that particular voltage we are calling as VTH. It means in order to get VTH from this particular network or across the terminal A and B, just find the voltage drop across this particular R2. Now the same voltage drop appear across terminal A and B. So that is the reason why first we need to calculate how much amount of current is flowing through this particular R2. So that is the reason why first what we need to do, in order to find the current flowing through this particular R2, first we need to find how much amount of current is flowing in the actual network. Okay, because whatever the current supplied by this voltage source directly flowing like this, and it will reaches this point, and after this point the current is directly flowing through R2. Yes or no? Because this is an open terminal network, that's why there is no chance to flow the current through this particular open network. That is the reason why the current supplied by this particular voltage source is directly flowing through R2, because in this case R1 R2 both are connected in series. Then the value of same applied voltage, that particular supplying the current to by the applied voltage will gives the current flowing through R2. So that is the reason why what we need to do, first we need to find the total current, that is equal to IT is equal to total applied voltage divided by total resistance. That is equal to total applied voltage is how much? 10 divided by total resistance is how much? R1 R2 both are connected in series. If you are going to neglect this particular open terminal, already we know that this is open terminal means we do not have any resistance. So that is the reason why what we are considering only R1 and R2. Now R1 and R2 both are connected in series means how to find the value of R2? Just we need to add these two resistances like this. Clear? So here the value of IT is equal to 10 divided by R2 is how much? 2 plus the value of R2 is how much? 6. That is equal to IT is equal to 10 divided by 8. Here the value of 10 divided by 8, it will gives what? 1.25. So 1.25 ampere is the current supplied by this particular voltage source. Now this particular IT is equal to 1.25 current is directly flowing like this from voltage source to this particular junction point, and after this junction point in this right side we do not have any resistance because this is an open terminal. Then the total amount of current is directly flowing through this particular R2. Now in order to find the voltage drop across this R2, what we need to do, just this current multiplied with R2 will give the voltage drop across this particular R2. So that is the reason why, so voltage across R2 is equal to, so total current into R2, that is equal to total current is how much? 1.25 into R2 is how much? 6. So if you are going to simplify this one, 1.25 into 6, it will gives the value of 7.5 volts. Clear? So this is the voltage drop across R2. Clear? Now this particular R2 is directly appearing across what? The open terminals. Just see here, I am redrawing the network like this. So this is a very, very important step. If you are clear with this step, then there is nothing in the Thevenin's theorem. Okay, so just see here, this one is A and B, and we are going to get the VTH across this open terminals. Now this one is R1 is equal to 2 ohms, and here this one is R2 is equal to 6 ohms. Now whatever the voltage drop we are getting across this particular R2 is what? So VR2 is equal to how much? 7.5 voltage. Now this is a 7.5 voltage. Now this voltage directly appearing terminal A across terminal A and B. So that is the reason why what we are doing. So the voltage of across R2 is equal to the voltage across the terminal A and B. That is the reason why the value of 7.5 is also called as the Thevenin's voltage. Clear? So the calculation of Thevenin resistance across terminal A and B is over, and the value of VTH, that is Thevenin voltage across the terminal A and B, is over. Now use these two values and now take the step number 5. That is, by using the values of RTH and VTH, draw the equivalent network provided by the Thevenin's theorem. Okay, now we know the value of VTH and also we know the value of RTH. Now by using these two values, what we need to do, just we need to draw the network like this. Now see here, so this is terminal A and this is terminal B, and this value RTH is equal to we got the value, that is RTH is equal to 1. This one, just see here, 1.5 ohms is the value of RTH. Now substitute here 1.5 ohms, and the value of VTH is equal to 7.5 volts. Clear? So this is a equivalent circuit we are getting from the actual network by calculating the value of this RTH with this particular VTH. Now step number 6. Step number 6 is connect the load resistance. Connect the load resistance which we initially disconnected from original network. Okay, connect the load resistance which we initially disconnected from original network across the above equivalent. So across the, what is the point number 6? Connect the load resistance which we initially disconnected from the original network across the above equivalent network. That is what? Terminal, across the terminals A and B. It means what? Across terminal A and B, we need to connect the disconnected load resistance. Now that particular, if you are connecting the load resistance here, that particular disconnected load resistance across terminal A and B here, then the network will becomes again like this. Okay, so this is the value of R3 is equal to 10 ohms, and this is terminal A and this is terminal B. We are connecting the terminal this R3 value across the terminal A and B, and this one is RTH, that is equal to 1.5 ohms, and this one is VTH is equal to 7.5 ohms. Now after connecting this load resistance R3 is equal to 10 ohms across terminal A and B, just observe what is our target actually. Current flowing through this particular RTH. It means what? Current flowing through this particular 10 ohms we required, yes or no? So this particular IR3, current flowing through this R3 we required. Now see here, just observe this one. We need to get the value of current flowing through R3, but after connecting this load resistance across terminal A and B, this R3 is directly connected with RTH in series. It means in case of series, the current is same, and in case of parallel, the voltage is same. So that is the reason why if you are connecting this load resistance across the terminal A and B, means the connection between the RTH and R3 is series. So that is the reason why if you are going to apply I is equal, if you are going to finding the value of current which is flowing in this particular network, means whatever the current is flowing through RTH, the same current is flowing through R3. Okay, whatever the current is flowing through RTH, the same current is flowing through R3. It means the total amount of current which is flowing in the this particular network is the current flowing through R3. That's why we can directly find the value of current flowing through R3 like this. Just see here. So here, so this step is very important. It means you have to know about what? You have to know about, in case of series, the current is same. Okay, in case of series, the current is same. It means what? We can directly find the value of current flowing through this particular R3 by finding the value of total current flowing in the network. Because in case of series, same means whatever the total current is flowing in the network, the same current is flowing through R3. Clear? So here, so total current in network, then the total current is equal to VTH divided by RTH plus R3. Here applied voltage for this network is how much? Sorry, this is VTH. Sorry. So this here VTH is what? 7.5 volts. Okay, 7.5 volts. So IT is equal to VTH divided by RTH plus R3. Clear? So here we know that the VTH is always 7.5 we are calculated, and the value of RTH is 1.5 and the value of R3 is 10. Now if you are going to simplifying this particular one, that is here see 7.5 divided by 11.5. If you are going to finding this value 7.5 divided by 11.5, if you are doing the calculation, then current flowing through this particular value, it will becomes 0.6521 amps. Clear? So now see here, you have to observe the most important point here. IT is equal to 0.6521 ampere, means the current flowing in this particular network is what? 0.6521 ampere. That same current is flowing in this particular network, that is means what? Through R3 also. So that is the reason why the last point is, so current flowing through the load resistance, that is R3 is given by, current flowing through R3 is given by, so the total current which is flowing in the network, that is equal to 0.6521 amperes. Okay, so this is a procedure we need to follow whenever we are going to finding the responses by using the Thevenin's theorem. Clear? So thank you so much for watching, and please do subscribe my channel for more updates. Thank you.